So, okay, in this lecture, I'm going to talk about the methods by which we can study the kinetics of chemical reaction. I've listed three such methods: volumetric, polarimetric, dialectometric method. Let me explain one by one in in different videos. The first video, let me explain volumetric method. Uh, Usually, in chemical kinetics we are interested to find out rate constant, rate of life, order, and etc. So this is the important measurements we do for a given chemical reaction. Let me assume A is converted into product. So this is in terms of reactant concentration, and this is in terms of product concentration. Rate is defined. So if you want to study the chemical kinetics, you have to monitor the concentration of the reactant or the concentration of product. In general, I should monitor when this reaction A is converted into product, and during this conversion I must find out change in concentration of any one of the participating molecule. Here concentration will decrease, here concentration will increase in case of product. So either I have to choose a reactant, or I can also use a product to measure its rate, and also to find out K, and also to find out T off, and also to find out order. So I must be I'm interested in finding out the change in concentration of the participating molecule during this reaction, right? This is in the case of uh, you can measure the concentration using volumetric method, right? So how will you do this? Let me take this ester hydrolysis reaction as an example. When you take large quantity of water compared to ethyl acetate ester, this reaction will follow pseudo first order reaction. Of course, that I'm going to conduct this reaction uh, as it follows. Uh, this must follow a pseudo first order reaction. So I have to take large quantity of water molecule. Then how will I study this reaction using volumetric method? I have to choose a convenient molecule. Either it is product or it may be reactant. I have to choose a convenient molecule to monitor its concentration. Ester is not suitable molecule because I should as I'm going to monitor its concentration, it should be titrated with any other molecule. So I don't find any other molecule to uh, react with this ester molecule. And the same way water and also ethanol. The best suitable molecule is acetic acid in the reaction mixture. Right? I can monitor the change in concentration of acetic acid. Right? Here HCl is a catalyst. Right? Here this is my reaction mixture. If I mix ester with the dilute acetic acid, dilute HCl, that is, you will have more quantity of water, you will have less quantity of HCl. That's dilute acetic acid. I will take about 100 ml of usually we carry out this experiment by taking around 100 ml of dilute HCl and some about 10 ml of ester. So as when you mix this ester and the dilute HCl at zero time, you have to find out, you have to take out some quantity of reacting molecule, some quantity of reaction mixture. Say I will take 10 ml of the reaction mixture. Then this 10 ml of the reaction mixture is transferred into a conical flask. here once you mix this two molecule, ester and dilute HCl, when you mix, the reaction instantly will start. Then very quickly I have to act. When I mix this two molecule, then 10 ml of the reaction mixture, very quickly I should take it out from the reaction mixture. I have to add into a conical flask where already you have ice. Ice must be already present inside this conical flask. If you transfer this 10 ml of the reaction mixture at 0 time, then the reaction will not takes place. The reaction will be stopped when you transfer this 10 ml of, when you transfer the reaction mixture into ice, the reaction will be stopped. So my aim is at zero time I have to stop the reaction. But here in this reaction in this reaction bottle, the reaction will proceed. We are not going to disturb. The reaction will take place, but at various time interval, I'm going to withdraw some about 10 ml of the reaction mixture, and at that time I'm going to stop the reaction using ice. For this reaction I use ice. For different types of reaction, for any other reactions, the suitable methods may be used. Suitable way, maybe adding some chemicals, or any other uh, mm, any other method you can stop the reaction. So here I'll repeat again, at zero time, the meaning of the zero time is the reaction should not react, the reactant should not react, the ester should not hydrolyzed. So I have to mix it. Literally the molecule should not react, but few molecules would have may be reacted, but that doesn't matter. Okay, we have to anyway, we have to accept it. So some 10 ml of the reaction mixture is taken out, that is transferred into a conical flask which already contains ice to arrest or stop the reaction. So at zero time I'm taking out the reaction mixture. So here I'll have ester and HCl, right? Here I have ester and the HCl, but I assume no molecule of acetic acid is formed. Then this is reacted with the base sodium hydroxide taken in the burette. So I have to fill the burette with the sodium hydroxide. So I here HPH, that is phenolphthalein, is added, then it is titrated. At zero time, the 10 ml of the mixture is poured into a conical flask containing ice, and the phenolphthalein is added. It is titrated with sodium hydroxide. Here ester will be there, and also dilute HCl will be there in the conical flask. So this content is now titrated with NaOH. Here I have taken NaOH. So this gives me the volume of sodium hydroxide required to react with HCl present in the conical flask. So I note the volume, corresponding volume at zero time. That is volume of NaOH. Volume of NaOH I'll note. This I call as V0. Volume of NaOH required at zero time is V0. And then various time, the meaning is at 10th minute or 5th minute. I'll take 10th minute. Exactly at 10th minute, again I have to withdraw 10 ml of the reaction mixture. See, already I started the reaction. I'm not going to disturb this reaction. This is kept in a water bath to maintain constant temperature. I'm not going to disturb this reaction, but at various time interval I'm going to withdraw this reaction mixture. At zero time I've taken 10 ml of the reaction mixture and titrated with NaOH, and again at the 10th minute I'm taking out again 10 ml of the reaction mixture. But now 0 to 10 minutes, so the reaction now proceeded to 10 minutes. 10 minutes the reaction is already took place. So you will find some acetic acid molecule in the reaction bottle. So here you are withdrawing the mixture and transferred into conical flask. Then you stop the reaction at the 10th minute. At 10th minute you have to stop the reaction. That's why you use ice. If you don't stop at the 10th minute, you will not know exactly what is the amount of acetic acid at the 10th minute. If you don't add ice, the reaction will proceed, then more amount of acetic acid will be formed. More extra amount of acetic acid will be formed, so you will not know the exact amount of acetic acid at the 10th minute. So my aim is to find out acetic acid amount of acetic acid at 10th minute and at 20th minute. Exactly at 20th minute I want to find out amount of acetic acid. So this reaction takes place inside. I have to take the reaction mixture out into conical flask where I should use ice to stop or to arrest the reaction, to find out at 10th minute the amount of acetic acid. At 20th minute the amount of acetic acid should be, to find out at 10th minute the acetic acid concentration. Okay, at 10th minute I'll take the reaction mixture and transferred into conical flask containing ice. So the reaction will be stopped, arrested, and I have to add phenolphthalein, and then sodium hydroxide is added. So at 20th minute, and the same procedure is repeated. At 30th minute, the same procedure is repeated. So at every 10 minutes time interval, I'm taking out 10 ml of the reaction mixture and transferred into conical flask containing ice, and phenolphthalein is added. This content is reacted with sodium hydroxide, and I'll find out the corresponding volume of sodium hydroxide required. Here, let me say, see, generally I'll call it as Vt. At various time interval, the volume of sodium hydroxide required is noted as Vt. So this is how you have to find out at various time interval. At various time interval, you have to find out the volume of sodium hydroxide required to react with the reaction mixture, content of the reaction mixture taken in the conical flask. Here you have to notice that at every 10 ml that you withdrawing from this reaction bottle, you'll notice acetic acid volume will increase, and along with acetic acid, at every 10 second at every 10 minutes, the acetic acid concentration will increase, right? And along with acetic acid, HCl also will be there. So your sodium hydroxide required to neutralize this content is actually HCl and acetic acid. Both the molecule will react with NaOH. But every time interval, acetic acid concentration will increase. At every successive 10 minutes, the acetic acid, you will notice acetic acid amount will increase. So correspondingly, volume required, so volume of sodium hydroxide also will increase. The required amount of sodium hydroxide or every 30th and 40th, every time will increase. And at V infinite, I call it as V infinite, where the reaction is completed. Then I'll take some minimum quantity of this reaction mixture. I'll have to heat. I'll take, again, say for example 20 ml of the reaction mixture is taken out. In this reaction mixture is heated. This is because I have to complete this reaction. The reaction should complete. So if I heat the reaction go faster, the molecule will react faster, and the reaction will complete if I heat. this reaction mixture for about 45 minutes to 60 minutes. So about 45 minutes to 60 minutes, if I heat the reaction content, the reaction will complete. And you take again 10 ml of this reaction mixture and titrate with sodium hydroxide. So the volume of sodium hydroxide is V infinite. Now I said this is a pseudo first order reaction. It will follow first order kinetics. Here A is directly proportional to V infinite minus V0. A, I know the A here is the initial concentration. Initial concentration A, we are indirectly relate with volume of sodium hydroxide. So if I subtract V infinite minus V0, what is that? V infinite is volume required at the beginning when the reaction is not started. So V0 is actually volume of sodium hydroxide required to neutralize HCl alone, where no acetic acid was formed at 0 time. So this V0 is actually volume of NaOH required to react with HCl in the 10 ml of the reaction mixture. V infinite is actually the reaction must complete. All the ester molecule literally should be converted into acetic acid. So 100% all the molecule is converted into product. The reaction is completed. This is done by heating the reaction mixture. So now you are taking out 10 ml of the mixture. Here in 10 ml of the mixture you will have acetic acid and HCl. So if you have 10 ml of 10 molecule of ester, here 10 molecule of acetic acid will be formed, right? So if you know at the end of the reaction, if you know the concentration of acetic acid, then you will relate with concentration of ester. So both will be same, right? Because one molecule of acetic acid will ester will give one molecule of ester. So at the end of the reaction, you are finding out volume of sodium hydroxide required to react with acetic acid at the end of the reaction. So this I can relate it with initial concentration. So that is why I write A directly proportional to V infinite minus V0. V infinite is the amount of sodium hydroxide required. When the reaction is completed, minus V0. This actually gives volume of sodium hydroxide. So, I'll write like this. I've taken acetic acid, this acetic acid plus HCl at V infinite. At V0, I'll have only HCl. At V0, volume of NaOH required is V0. At V0, volume of NaOH required is, that volume of NaOH is required. V0 volume of NaOH was required to react with HCl only at V0 at time 0. But at time infinite, all the ester molecule is converted into acetic acid. So you will have maximum number of acetic acid. So further maximum number of possible acetic acid plus I will have HCl. If I subtract V infinite minus V0, I'll get volume of sodium hydroxide required to react with acetic acid. So this acetic acid concentration is related to the initial concentration. That is why A is directly proportional to V infinite minus V0. Then A minus X is directly proportional to Vt minus V0. Vt minus V0 is actually directly proportional to X. That is, at various time, at 20th minute, the amount of sodium hydroxide required to neutralize acetic acid formed at that time, acetic acid form is Vt minus V0. So A minus X is directly proportional to V infinite minus V0 and minus Vt minus V0. So A minus X is directly proportional to, so this V0 get cancelled, you will get V infinite minus Vt. So now substitute. In this equation I'll get log A is V infinite minus V0 and here V infinite minus Vt. So you can find out K value using this equation. And also you can convert this into a straight line equation and you plot time in the x-axis and then the y-axis log V infinite minus Vt. From the slope you can find out K value. So this is how you can use volumetric as one of the suitable method to study the kinetics of chemical reaction.